Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. On this video, we do the first 4 exercises on the handout called Graphing Trig Functions Part 1. All right, we're going to do the solutions to the exercises from Graphing Trig Functions Part 1 handout. And in that, we began by figuring out how to graph y equals the sine of x. And we chose some values for x. I chose some easy values for x to get started and figured out the sign of each of those values, which gives you these 5 ordered pairs. And of course, there's infinitely many ordered pairs. But let's start with these 5 ordered pairs, which I've indicated with these blue arrows where they are. There's 0, 0, pi over 2, 1, pi 0, 3 pi over 2 negative 1, and 2 pi 0. And if we connect the dots carefully, if we do some more ordered pairs, we get this smooth looking curve called the sine curve. Now notice the arrows go, I have to have arrows at the end of this because this goes on infinitely forever and ever. But what you see here are 2 periods of sine. In other words, before it starts repeating, this is 1, 2 periods of pi, and a little bit more. So we're going to use this now to graph the first problem, which was y equals 2 sine of x. So if we have here that this is y equals the sine of x, then if I have y equals now 2 times the sine of x, all of the y values will be multiplied by 2, because imagine, this is the sine of x, the y coordinate, right? And now we're going to do 2 times the sine of x. So this will give us these ordered pairs. If I just multiply that 0 by 2, I get 0. I'll get pi over 2, 2, because I'm multiplying that 1 by 2. I'll have pi, well 0 times 2 is still 0, etc. And we get these ordered pairs to do y equals 2 sine x. Now let's see, what does that really look like up here? Well, let's do it an easy way. Instead of going pi over 2 up 1, I would have to go up 2 spaces. So of course what I could do is put an ordered pair up here, not an ordered pair, but I could extend the y-axis more and have 2, and I'd have this line up here, right? And I'd have pi over 2 up 2, and over here my 3 pi over 2 would go down 2. So that's perfectly fine to do. Here's a real easy way to do it. If I just change this y value and I call it 2, then I've got it. So if you want, you can put a little space here and say, hey, that's 1 and that's negative 2. Notice it looks exactly the same because you get to choose the values on the x and y axis. Now, of course, that's why it's so important to label your x and y axis. All right, but if this is 2, then that's where that point is. If this was 1 still, of course, this point would have to be up about this high. Okay, so that's one way of easily getting y equals 2 sine of x. This is still 2 periods, and we would say that the amplitude, which is what I also asked you to do, is the amplitude is just the absolute value of this number right here. Okay, so it's the absolute value of that, which is going to be 2. So the amplitude is 2. So that's how to do the first problem, y equals 2 sine of x, the amplitude of 2. That's exactly what it looks like. Now, some people like to write these ordered pairs in a chart and then just multiply each of the ordered pairs by 2. So I'm going to do this exact same problem, writing it out in a chart. All right, so let's start off again with y equals sine of x, and we're going to graph y equals 2 sine x. And how can I use this chart for sine of x to do that? Well, my y values just all get multiplied by 2. So if you want, you can show 2 sine x, which would be the new y value, you just multiply each y value by 2. So it'd be 0, 2, 0, negative 2, 0. And the ordered pairs you're looking for here are here, x, y. There's your x and there's your y. There's your x and there's your y, etc. So let's see. We've got 0, 0. We've got pi over 2, 2. So I go over to pi over 2 up 2. Pi 0. 3 pi over 2, negative 2. And 2 pi 0, and that would be 1 period. And then it starts repeating after that. So I would have these other ordered pairs. Then, of course, the trick is to try to graph a nice smooth curve. I'm going to try to do that. So it looks something like this. Now you may say that doesn't look the same as my other graph. Well, it's because of how I am labeling my x and y axis. So it may look skinnier than my other one, but it just depends how I label my x and y axis. Now remember on the x-axis, 2 pi, that's about 6, right? Because pi is about 3.14, so it's a little bit bigger than 6. So each of these markings is about 1.5 here, but it's very approximate anyway. The x and y axis simply doesn't have the same markings on it. So that's what the graph of y equals 2 sine of x is. And again, the amplitude is going to just be 2. Remember, the amplitude is just half the height from the smallest to the highest point. So you notice from the very bottom to the top, that's 4 units. It's really half of that. So you could sort of like think about breaking the graph in half and just looking how high does it go up or how high does it go down. Simple way, absolute value of this coefficient of the sine of x. So there we have y equals the sine of 2 sine of x. All right, the second problem is y equals 1/2 sine x. We could do this exactly the same way. I can say, well, what would 1/2 sine x be? Well, all the y values would be half of this y value. So it'd be 0, 1/2, 0, negative 1/2, and 0. And we could do the same thing, just graph those ordered pairs and then make a nice smooth curve. Make sure you don't make your curve look like, kind of triangular. There's no points in it at all. Or let's look and see how we graphed that very first one. Remember how I graphed y equals sine of x, and then I changed this and called this 2 right here? So if I just want to fool around with this, I could take this exact graph and call this place up here 1/2, and that will do it. So you can either each time, just go ahead and graph the point 0, 1/2, or simple way to do this, I could just call this point right here 1/2. So this is what it would look like if I did that. So here I'm just have actually y equals sine of x, the curve, but notice I'm holding off on how I'm going to label my y-axis. Since I want this to be 1/2 sine x, I'm just going to call this 1/2. And there you got it. Now if this is 1/2, this is automatically negative 1/2. You don't really have to put the point down on both sides, but it's kind of nice to do that. Now I've got the graph equals y equals 1/2 sine x. This is pretty cool. So check it out. What if this would have been y equals 4x? What if that was a 4? How would this be different? Well, instead of calling that 1/2, I would just call that 4. That's a tricky way to do it. And then you should make sure it's really correct. Like if you had this ordered pair here, pi over 2, if you put in pi over 2 for x, sine of pi over 2 is 1 times 4, and you would get that ordered pair, pi over 2, 4. So verify that it really is the correct ordered pair right here. So, but this one was y equals 1/2 sine x. So let's go back and say what it really was for number 2. This was 1/2 sine x. So that's what the graph of 1/2 sine x looks like. If you don't like doing this and you'd rather like mark the label of 1 and then go down and make it, look not as high up, that's perfectly fine. So either way works just as well. All right, let's go on to number 3. Y equals negative the sine of x. All right, again, here is y equals the sine of x, where that would be 1 right here, if this was just y equals sine of x. And here were our ordered pairs here for y equals sine of x. I want negative the sine of x. So what's going to happen this time? Well, if I want negative the sine of x, I'm going to take the opposite of all the y values, right? Negative 1 times all the y values. Well, that's going to be 0, negative 1, 0, positive 1, and 0. What would those ordered pairs look like? So let's say that's 2 pi. And let's say that is 1 and negative 1, just to get started here. So we're going to have 0, 0. And then I've got pi over 2, negative 1. Oh, it's down here. And then pi 0, that's back up here again. 3 pi over 2, positive 1. And 2 pi 0. And then it starts repeating, so I could do these same order pairs over here. It's kind of a continuation if I want to get 2 periods. And then I try connecting the dots here carefully. Oops, I noticed I didn't do the right dots right here. Sorry. Those dots should be right there, right here, and right here. Having a little trouble erasing this little dot. There we go. Okay, so I try to connect the dots here. That's always the tricky part, trying to make it curve. Notice if you just sort of do a little at a time, it's easier. Looks sort of like that. And coming back up through here and starts curving. Okay, so there we have y equals negative sine x. Compare that to y equals sine x. What's the difference? Instead of the hump right here, 0, 0 going up first, it goes down first. So if you've got a minus sign in front, basically it's flipped. When it was above the axis for y equals sine x, it's going to be below the x for y equals negative sine of x, and that's what the graph looks like. What about the amplitude? How high is it? It's got exactly the same height. What's the coefficient here? Negative 1. What's the absolute value of negative 1? 1. So the amplitude is still 1, and there's the graph of y equals negative sine x. All right, let's do one more problem. Let's do the last one, which is y equals negative 2 sine of x. So let's say this was a negative 2 in front of here. And this is problem number 4. Y equals negative 2 sine of x. What's the only thing that'll change here? Think about that. Well, so this over here is going to be negative 2 sine x, right? So all my y values get multiplied by negative 2. So the only difference is these two right here, because multiplying 0 times anything that stays the same. That'll be negative 2. That'll be a positive 2. So this one order pair, pi over 2, negative 2, this is going to be down here at negative 2. And instead of this being 1 and negative 1, here's the easy way to do it. I love that you get to label your own axes. If that's negative 2 and that's positive 2, there you've got it. There's the graph of y equals negative 2 sine of x. Now always check and make sure that it's really true when you plug in like this value of x. Make sure you really get the y value of 0 if you plug in this value of x. Like if you put in 3 pi over 2, if you really do it. What's the sine of 3 pi over 2? Figure that out. Well, that's going to be negative 1. And then negative 2 times negative 1 is 2, so I do have the right ordered pair. So the amplitude here, again, absolute value of the coefficient. So the absolute value of negative 2 is 2. And there are the first 4 problems on the worksheet. Please visit my website at yourmathgal.com, where you can view all of my videos, which are organized by topic.